Yeah, hello. Like a virgin for the very first time. Hello there. It's amazing to hear. See, I've never been to one of these Raspberry Pi jams before. Raspberry Jam.
Oh, called Pi Jam.
Whatever. Right. These things, right? All the people come to celebrate programming using this small device. I've never been to one before, and it's amazing how many people there are who are enjoying themselves. So I thought that I'd talk for 25 minutes about sorting algorithms. So I've started off this thing, and obviously sorting is really important, and we should all learn how to do sorting. It's an algorithmic exercise. So the way you do it, you have like a list of numbers like 10 or 6, 3, 5, and I don't know, minus numbers as well. You can do that on zeros. And you do dot sort, right? And then that's it. Oh, you need to print it out. Well, there's the answer there on the right, -1. That's sorting, okay? Now, you can obviously go into detail about how this works, but who cares? Like, who actually cares about sorting? Who's done some sorting recently in their lives? Right, nobody. But some people, okay, what did you sort?
I sorted my shopping.
Sorted your shopping. Did you enjoy it? Was it really fun? So some people might find it fun, but not many people do. So when you think about algorithms and teaching and education or programming, and you think, well, I've got to teach them sorting. No, don't do that, because, well, unless you can find an amazing way to engage kids in sorting, right, and it actually is relevant to them, that they care about, they go, yes, I'm going to go out and sort some stuff with computers, then don't do it. Think about what are the things that they care about, that they can interact with, that means something to them. Because sorting actually is quite difficult. You've got to unless you're doing the really basic one, like bubble sort, which is really useless and no one ever does, you've got to do things like recursion and variables and splitting and lists and lots of stuff, right? Which is really interesting computer science, but you're not going to engage them if they don't care about the outcome. So one of the things I've been thinking about in terms of teaching children how to program is how can I do something where the outcome could be potentially interesting to them, where they actually it means something to them in their lives. And so I built this thing called Sonic Pi. Who's heard of Sonic Pi before? Oh, that's amazing, cool. I'm quite pleased about that. Who's played with Sonic Pi? Great. Who's played with Sonic Pi version 2? Oh, excellent. Okay, so it's a small number. So I've been working on it. I work with a teacher called Karen Philbin. She's absolutely amazing. And we developed the first version of Sonic Pi. And all it really did was to make nothing to do with sorting. It was to do with trying to think about how to make programming really easy to get started with. So you start with this application, and this is exactly the same on the Raspberry Pi as it is on the Mac. Start with this application, and the first program you write is the word play and a number, like 80. And then you think, that's pretty cool, and then you think, well, let's play that. And then you hear this beep. That's it, that's your first program. So it's as simple as that. There's no file, workspaces, directory structures. And that was because when I was coming up with lesson plans, naively I thought, I'll read the curriculum that's been proposed, I'll write some lesson plans which might be interesting, gave them to Carrie Ann, she said, well, they look really nice lesson plans, but there's no way you can teach all this in one lesson. I obviously overestimated by a huge amount. And I didn't really understand, I was like, well, really? There's not that much information in this lesson plan? Really? I can't teach that? Until I went to one of her lessons, she was like, Johnny, James, sit down, turn me off the table, so all this kind of nonsense. And then she's like, I'm going to say something, 5, 4, 3, stop messing around, 2, 1, and then she'd have maybe a couple of sentences she could inject. And if you're going to talk about file systems and projects and workspaces, that's your lesson done. So this is a way to try and get bootstrapped straight away into something where the code is super simple. The way to get started is open the application, write that, press run, and the results are meaningful. There's a sound. But it's not just about play 80, that's not great. You can play any number. Any number. Well, what other numbers are there? Well, 86, that's quite a good one. Or like no numbers. So then we can start talking about how numbers are representative of pitch. Higher numbers mean higher notes, low numbers mean lower notes. And you can talk about ranges of audio perception if you want to, like note 10. It's like really low, and if you haven't got like a crazy subwoofer like I carry around in my bag, there's no way you can hear that. So you're talking about perceivable ranges. Like similarly, 1,000 is too high to hear, or hearing it won't reach it. So we already, with one line of code, we've got abstraction, we've got numerical systems, we've got pitch, we've got all sorts of stuff we can talk about. But it doesn't stop there. So I can play note 80, and I can start thinking about a program as a sequence of operations. Do this, then this, then this. So play that, sleep for I know a second, play 70, sleep for 0.5 seconds, play 75, sleep, that'll do. There we are, that's my first tune. And so you give the children this and they'll spend an hour with it, writing play, sleep, play, sleep, play, sleep, play, sleep for ages. And they have a lot of fun. And so that's already, you've already got tons of stuff you can do with that. And then you think, well, okay, how do I make it a bit more rhythmical? So you can say, I don't know, loop, right? You can say 5 times, play this, and this, and this, end, sleep for 0.25. Oh, I've got a syntax error somewhere. That's because I need a do. Right, and off we go. So we can start putting looping constructs in there, we can put conditionals in there, so you can start to actually express interesting computation. Now, there's a whole set of lesson plans associated with this. I've only got a few minutes to talk about it, so I won't go into more detail than this at this stage. But if you go on the raspberrypi.org website, there's lesson plans, there's teaching materials, there's exercises on there, which work with the first version, not the recent version, but everything I'm showing you here is good. But I'm not, to be honest, the computing curriculum is pretty cool, but it's not that interesting for me, because I'm excited about new things, new ways of programming, new things. And the thing which made me realise that the computing curriculum wasn't as exciting as it could be was when the children, they did this, right, did these loops and structures, and they made a baseline, and they did a similar thing for melody, and they said, right, so how do we play them at the same time? Like, well, actually, that's pretty tough. You've got to do threads. And we don't teach that until university level. How am I going to do that? So, well, okay, we'll teach you threads. So we taught them threads. So it's very easy to do this. So you sort of write in, thread, do, and then end. Now this happens the same thing as the thread, but it means I can also write play, no, loop, do, play, 30, sleep, 0.25 seconds, end. So I've got two things going at the same time. Notice also how in this language, it's not like Python, I don't have to worry about the indentation, so they can be a bit more messy and that it still works. That actually is a really nice feature. So this is where I got with CamJam, was basic structures, timing, different notes of abstractions, if statements, conditionals, iterations, and threads. The problem was, though, it was where can we go further with this? Where's interesting? And so I was thinking about how we can take this into other lessons, not just computing. So can we see this as a musical instrument? Is it possible to put it in the music lessons? And so we've started a project to do exactly this. It's called Pi Live Encoding, and we're actually working to do exactly this. And so the thing is that this isn't that exciting in the music lesson, so what is? Well, perhaps you might want to do some drums, right? You're a kid, you want to say, I want to sample the Amen break. Drums, one line of code. How cool is that? And then you say, okay, well, that's pretty cool, I want to do something more. I want to have a drum loop. Right, so what's a loop? Well, you use a looping structure. Loop, do, I need to play the sample and then seek for some time, so I seek for the sample duration, so the length of loop Amen. And then I end. So this is the same as play 50, seek for a second. Let's just play this loop Amen sample, but I've got Amen break going on forever. The thing is now I can start to do like random stuff, so I can say play the loop Amen, but choose the rate to be either 1 or 1 or 1 or 1 or minus 1. Let's make it. Let's actually take a few away these. Dot choose. So what I'm doing now, I'm playing it randomly, either backwards or forwards. Right. So already I've got a bit of an algorithm. That's like my sorting algorithm. I'm choosing a note from a number from that list randomly, and I'm using it as a rate value. And that's just the same as sort of, you can see it. Sample loop. Got a bunch of these guys. The compass one's quite nice. Backwards. So it's very easy to actually think about how you might play with this. Of course, you don't have to stop there. You can also imagine things like adding some reverb. That's the usual thing people want to have when they're doing music. So I say with effects, reverb, do, sample, some reverb going on there. No variables here at all. That's pretty cool. So where can you go with this, musically? Well, not too hard to do something like this, which is changing the cutoff value of a filter on a loop which is going around with some drums, right? There's only like 8 lines of code there, but we're in the club already. Randomisation going on. This runs on the Raspberry Pi. Right? It's not just my Mac that's doing this. This actually runs on the Raspberry Pi exactly the same way as it's doing here. And already here, it's slightly more advanced, but when you actually want to do something more complicated, you need to use a bit more code, but not too much more. So we're going from the simplest thing is super easy to do, to when you get to do more interesting musical things, it's possible, you just need a bit more structure and a bit more code. How long have I got, by the way, in my talk? I've no idea.
You've got about 5 minutes.
Perfect. Actually, at this stage, you've got any questions? Probably the best thing, and I can then answer them with code. Yes?
How easy is it to add samples? Are they MP3s?
So the samples are trivial to add, so they're all WAV files or AF files, so it's like the basic format, so not MP3s, because that's an encoded format. If you have a sample in the file system, so if you put it on your USB stick, on your Pi, you plug it in, then you can say sample, whatever it is, like home Pi my samples foo.wav, and that will play it. So you can, instead of putting the keywords in, you can actually do this. So if you're doing lessons, you can actually get your samples into a directory, and then you can put those samples on share them across all the Pis, and then you can either get them to put the names of the samples in like this, but you can actually say use sample pack, and then the directory name of the samples, like this, and then you can say sample foo, and they'll pull the one out from your sample pack. So you can get the same kind of behaviours with the built-in ones, but with your own sample packs. So if you want to actually work with your own samples, that works very well. Any more questions? Yeah?
Exporting. So I'm playing with the original version of Sonic Pi at the moment with a group of kids.
Yeah.
And I might have one lesson and the next lesson, and the kids can go and destroy that other group's work because they just come in the workspace and delete it.
Right.
I see on the new version you've got to record and save.
Yeah,
you have to record those to MP3
to WAV files. Yeah.
WAV files, yeah.
Yeah. So like, let's try and have a go with this. So press the record button. See, it's now recording, and then press the record button again. It's now doing work. Stop. So then I recorded it down here where it asked me to, and I can hopefully play it back from the file system. So I'm recording. So they can save that, and then the save file saves it as text, so you can actually go and save it around. But these things I'm working on for version 3. I've got some really good ideas about how to actually persist these across lessons and to share them across schools as well. Okay. So it's something I haven't really addressed yet, but yeah, definitely that's something in plan. Your question?
Does it run on Windows?
So it runs on Windows, yes. It runs on all platforms, but I'm only currently supporting Raspberry Pi. So I have development versions of all platforms running, so if you want to talk to me, I can help you get it running. In November, December time, I'm planning on releasing sort of nice versions you can actually install yourself easily for all the other platforms. No questions? No? I've got 1 more minute?
Yeah.
Let's try and show some more stuff. Like let's think about what you can do with this, because there's so much fun you can have with this. I guess the last thing I show you is like this notion of live coding. So what I've shown you is like you can write some code and you can play it and you can stop it and you can play it and stop it. But what's really fun is if I define a function called foo, which is sort of playing note 50, I don't know, sleeping for 1 second, and I loop foo like this, I can then get it running, and I can change the note as it's going, which is quite nice. It's quite loud. But I can also, I've got all these different synths, so I didn't show you, there's, in the help menu you can look at all the different synths you can use. A quite nice one is D saw. So let's try that. Use synth D saw. So you can change the synths on the fly. Get rid of this guy. And then you can start doing things like changing its filter. So cutoff is 70. So you can change the sort of the timbre of the sound on the fly, or like 80. Let's change it to a lower note. And then maybe stick it for less time. But this sounds nice if you have a random thing. So if I choose a random value between 50 and 100, and then have it like this, and then maybe have a release. I'm not suggesting you understand all this I'm writing now. We can see there's not much. So I also use chords. You can see that, you can read that, there's not too much code. You can learn that, all of you. Not just children, we're not talking about here, we're talking about everybody. And I remember listening to a radio interview with an old lady, she was 100, and they asked her if she had any regrets. So I'll finish on this if that's okay. And she said yes. And the interviewer said, oh, okay, what was your regret? She said, well, when I was 80, if I'd have started playing the violin, I'd have been playing it for 20 years now. So that's worth thinking about. So it's never too old to learn how to program. Especially, it's never too hard to learn how to program if the thing you're doing is something you enjoy and it's something that actually has results in you. So don't do sorting, do music. Thank you very much.